Our next speaker is Dr. Michelle Nelson out of the University of Michigan. She is the research program officer for the HHMI-funded grant to improve science education at the University of Michigan. Dr. Nelson has a PhD in science education and has worked in K-12 and college settings to study and improve science teaching and learning. She'll be talking to us about making student work more authentic in an introductory college chem lab. Let's all give a warm welcome to Dr. Michelle Nelson.
Hi, I'm Michelle Nelson, and I would like you to think back for a minute to your introductory college chemistry lab course, maybe the first lab course that you took, or maybe it's an introductory biology lab course. What was it like? What was it not like? Did you feel like you were doing the same kind of work that real scientists do? Show of hands if you thought you were a real scientist. Okay, so as you can see, I'm dressed like a real scientist today. And my talk is going to focus on this term authentic. I'll first explore the reasons why it makes sense to make lab courses more authentic at the college level. And then I'll kind of unpack this term authentic. What does it really mean for an activity to be authentic? I'll go into how we are making some of our work at the University of Michigan that students do in their lab courses more authentic to what real scientists do, and share a little bit of data on what students' reactions to these curricular changes are. And then finally, I'll explain why this should matter to each and every one of us in the audience today. Okay. So, first, why make lab work more authentic at the college level? What's the point? Well, as you can see on the right side of the slide here, we're preparing future scientists. That's one major goal of doing this work, making it look more like what they're going to do when they get out of college, so they'll be better prepared. We're also preparing lots of students who are not going to go into science or STEM-related careers. However, they will use the same kind of critical thinking skills and logical approaches that their STEM career counterparts will use in their own jobs, be it in law, in medicine, whatever field they go into. So there's value in preparing them along those lines as well. And finally, we want to prepare scientifically literate citizens. We want just people in general who can sift through the messages in the media and determine what's fact and what's fiction. So how do we get there? Well, we draw on learning theory, and we draw on educational research and practice, and we work to more effectively develop student skills, improve learning, and in turn promote these more positive learning attitudes, positive attitudes toward science and STEM careers in general. Another piece of the puzzle is this goal of increasing educational coherence. And so you've heard a lot today about the next generation science standards, three-dimensional teaching and learning. As you probably know, we have no standards at the college level. We have no formal science education standards at the college level. So the goal is really to try to continue the work that K-12 educators are already doing to lay the foundation for thinking and learning in these really rich ways, continue that into the college level. So, I mentioned this term authentic a few times. What does it actually mean? Well, I'm going to draw on the work of Harrington and Oliver here, who developed a framework for authentic learning environments. And one piece of their authentic learning environments is this authentic activities. So, authentic activities have real world relevance. They're not just these abstract concepts that are taught divorced from how they are applied in real life, but they actually are married to the context that they appear in. They're ill-defined, so there's not one defined problem or one defined solution necessarily. They're complex, they have multiple parts to them. And students are involved in defining how to solve the problem or how to reach the goal that they're trying to reach. They're sustained over time. And they give students opportunities to decide what pieces of information are relevant to the problem solution and which pieces are maybe ones that can be left to the wayside. Students work together in these authentic activities. And finally, authentic activities combine perspectives from multiple disciplines. So out in the real world, you don't have projects that are strictly science. They pull in language arts skills, they pull in maybe business skills as well, and we want to bring more of that into these lab courses. So you're probably thinking, wow, this sounds great. Whoa, wait, how am I going to do this in my classroom? There's so many challenges getting in the way. Well, in the interest of time, I'm going to only focus on 3 of these features of authentic activities and how we're transforming the lab course at the University of Michigan. And I think a lot of these strategies that we're employing will help you in your own classrooms as well. So first, I'll talk about collaboration. In the previous version of this laboratory course, we had students working at their own pace, individually, as they proceeded through a set of labs in a lab manual. So they kind of did what they wanted to. They had to complete a certain number of labs over the course of the semester. Now, in the same course, students work in groups of 3 to 4, and they do group work throughout the semester. Every week is group work. The second week of each 3-week module in the course is a dry lab week. So students come to lab, but they don't actually do any bench work. They engage in jigsaw activities, and I'm guessing most of you are familiar with what these jigsaw activities are. Students develop expertise in a piece of the overall topic that we're working on, come back to a home group, and then teach each other their little portion that they knew really well. So they're working in groups throughout. One thing that we are concerned about, though, with a lot of this group work is the occasional social loafer or the hitchhiker, the student who slides by with doing very little work. So to safeguard against that, we've built in some individual accountability into the course. Each student in the course has to upload his or her own lab notebook pages after each lab period. And there are a number of writing assignments, and this kind of touches on the multiple disciplines aspect. Number of writing assignments that students have to do in the course, and each person does their own writing assignment. Another feature of authentic activities was that students are involved in defining the tasks and subtasks that they engage in these activities. So in the old version of this lab course, students had the lab manual, like I mentioned, and they had a bunch of experiments already laid out, basically protocols to follow to generate data, confirmatory data mostly. In the new version of the course, we have students become acquainted with techniques in the first week of each course module, and then in the second week, they gain these new concepts from their jigsaw groups, and they work together to design an experiment. So they come up with their own research question, they form an hypothesis, and they develop a procedure based on the procedure that they did the week before. Okay? Then in the third week of each module, students actually carry out their experiments that they designed the previous week. So when they carry out their work, they have to figure out who's going to do what in the lab. And then the third feature of authentic activities that I want to highlight today is this idea of real-world relevance. So in the previous version of the course, students were given reactions to carry out, but the reactions were really not contextualized within anything familiar to students. Here, we have students working with compounds that they've heard of before. So for example, students learn ester hydrolysis in the context of local anesthetics. They actually get samples of lidocaine, and they have to manipulate temperature, pH, things like that to see how long it takes the lidocaine to break down. Students also know the hows and the whys of the lab techniques that they learn in the course. So it's not enough just to know how to carry out a thin layer chromatography, for example, but students also know when it's appropriate to use this technique and what they can learn from the data that they generate. And finally, we have students engaging in purposeful work. And I've got the image of the green chemistry here as a cue for that. We've developed a green chemistry module where students carry out an organic chemistry reaction in 3 different ways, and then they analyze which of these ways is the greenest or most eco-friendly. The reaction that they carry out is one that's very important for pharmaceutical and agricultural applications, so it is also grounded in a real-world context. Okay? So students overwhelmingly like the ability to design their own experiments in the course. They also like learning lab techniques very thoroughly, and they like working together in the course. We also find that students would like more explanation of the procedures that they're carrying out, which is a cue to us that we need to do a better job of laying the foundation and being explicit about our expectations of what they will do in the course. They also want shorter experiments, and this is the sustained over time investigations. They complain sometimes that it's really hard to get everything in a 3-hour lab period, which we're working on that as well. So you can see that students, in their own words, said that they liked this realistic simulation of a lab environment. They liked working together, some of the most interesting work that they've done in a chemistry lab. So why should you care? Well, one takeaway message is that we didn't reinvent the wheel here. We took existing labs and basically just switched them around to fit our instructional model. So not an expensive process, not a hugely time-consuming process, but something that's very doable in a reasonable time frame. Second takeaway here is that students really appreciated the authenticity. I just showed you a couple quotes and some data. Students at all levels love to be scientists, right? They're very curious by nature. So another thing that can be implemented into your own situation. And then the third takeaway is really your homework from this talk. And that's that I'm going to ask you to put together the pieces from my talk and the talks that you've heard before now and the talks that you'll hear after me as you think about how authentic work and next generation science education standards and teacher professional development all kind of come together into improving science teaching and learning for all. Okay. Thank you.